the chain rule. The chain rule is used to find the derivative of a composite function. It is only applicable when the function is a composition. The chain rule can often be confused with the product rule.
So, for our first problem of 4, we have the easy problem. So this problem says find y prime for y equals tangent of x squared plus x plus 1. So I already took the liberty of doing it, but the first step you want to do is figure out what the box is, because we know that this is a composition, so there obviously has to be a box. So I identified that the box was the x squared plus x plus 1. So now that we have that established, we'll go to the first step. So for the first step, we can write y prime equals secant squared of box. So for this part, we're just taking the derivative of the tangent, or yeah, just the tangent, and not the x squared plus x plus 1, none of that. We're just leaving that as a box for now, because we want to go back to on our calculus, we have our equation for a chain rule is f prime, which the f would be the tangent, the g would be the x squared plus x plus 1. So we want to do f prime times g of x. So this is our f prime, the derivative of tangent, times g of x, which is just left alone, times our g prime of x, which is our box, and so this is the derivative of the box. So we have that. Our next step would then be, our next step is then y prime equals 2x plus 1. I just put that in front. I don't know we're just supposed to do that in class. So the 2x plus 1, that goes in the front of the secant squared of, and then, so we have this box. This was the box originally, and we just plug that back into the end, to the final answer, which will then be 2x plus 1 times secant squared of x squared plus x plus 1, and that'll be your answer.
Our next problem is the two medium problems. So now we want to find y prime if y equals sine of cosecant of x squared. So our first step is to identify that it is a composition, and next is to identify what is in the box of this composition. So cosecant of x squared is the function in the box. So first we want to, and then there's also a second composition, and so we want to identify that x squared is in a circle. So first you take the derivative of sine of the box. So it's cosine of cosecant of x squared, because the box is left alone. The next step is something people often forget, and that is to multiply the first function by the derivative of the box. So the next step is the derivative of the box is negative cosecant x squared cotangent x squared. And the third and final step is to multiply by the derivative of the circle, which is 2x. So you bring the negative around to the front, and you're left with negative 2x cosine of cosecant of x squared times cosecant x squared cotangent x squared. And there it is. Next problem is find y prime if y equals sine of the square root of 6x squared plus 2. So first we have to again identify that it is composition, and it's not on our calculus, so we have to identify what is in the box first. And that is the square root of 6x plus 2, but we're not done there because there is a second composition, and that is 6x squared plus 2 is in the circle. So again, we want to take first the derivative of the outside function, and that is going to be cosine of the box, which is cosine of square root of 6x squared plus 2. Then we want to take the derivative of the box, which is 1 over 2 times the square root of 6x squared plus 2. The third and final step is to multiply by the derivative of the circle. Of course, the derivative of a constant is 0, So the derivative of the circle is just 12x.
And then I'll butt in right here. So we kind of skipped a step right here. So you could have written it as instead of just jumping to this step, you could have done it to the 1/2 and done that. So we just skipped that step right there. I don't know, just make it a little more clear. We skipped that step to do 1/2. Any function in the square root will just be 1/2 times whatever's in the square root. So that's why we did that.
And so your final answer, you're left with, oh, this isn't the final answer. So then you multiply everything together and you're left with 12x times the cosine of square root of 6x squared plus 2 all over 2 times the square root of 6x squared plus 2. And your final answer, you would simplify it, and it would be y prime equals 6x times cosine of square root of 6x squared plus 2 all over the square root of 6x squared plus 2.
So for our last problem, we have the hard problem. And for this, we are asked to find y prime for y equals cotangent, cosecant of the square root of ln of 4x squared plus 3x plus 2, which at first seems extremely hard and complicated. It just seems long, and that's really what the whole problem is. It's not really labor, like it's not hard to do, it's just a lot to keep track of, a lot of work. So to keep track of everything, we'll start off by realizing what our box is. So we have the cotangent of our box right here. Our box is this cosecant of square root of ln of 4x squared plus 3x plus 2. So we have our box now. Now we want to find what is our next thing. So inside of our box we have the cosecant of this circle. And this circle is going to be the square root of natural log of 4x squared plus 3x plus 2. So now we have our circle, and inside of our circle we have another I guess you could say shape that we want to have, and we'll call this cloud. And this will be our cloud. So now that we have everything figured out, it's time to solve the problem. So for our first step, we'll do y prime equals negative cosecant squared, which is the derivative of cotangent box. So negative cosecant squared of just this whole box right here times negative cotangent, or times the derivative of our cosecant circle. So times negative cotangent, just circle, times cosecant of our, what's in the circle right there. So that's what we have. Times our, times the derivative of our circle, which would be 1/2 times the square root of natural log of 4x squared plus 3x plus 2, which we explained earlier how we just skipped that doing the 1/2 exponent step. So that's what that is right there. And then we'll multiply that by the derivative of the cloud, because in this circle we had our little cloud. So the derivative of the cloud would be the natural log of 4x squared plus 3x plus 2, which is 1, just simply 1 over whatever this cloud is, 4x squared plus 3x plus 2. And then we want to find the derivative of, okay, we found the derivative of the circle, which was this. And we're multiplying it by the derivative of our cloud, which is 8x plus 3. So that's nice and simple. So now we have this whole confusing mess, and we'll simplify it at this last step. So for the last part, we'll do y prime equals this 8x plus 3, we'll put that at the front, times cosecant squared of cosecant times square root of natural log 4x squared plus 3x plus 2, which was this first part. So we have that. Oh, and one thing to point out, there's no negative sign in the answer because these two negative signs canceled out. So we have no negative signs to worry about in the answer. So we have this cosecant squared, I already said all that, times our cotangent of square root ln of 4x squared plus 3x plus 2 times cosecant of our square root of ln of 4x squared plus 3x plus 2. And this is all going to be over, in parentheses, 8x squared plus 6x plus 4 times the square root of natural log of 4x squared plus 3x plus 2. And that should be your final answer. So, yeah, I hope you enjoyed the presentation.